Okay, so now we're going to do radical equations. So, couple things. Checking for extraneous solutions. Oftentimes, both answers, if there's two answers, both will not work. Um, so you have to check each time. Even though it works out algebraically, when you plug it back in, it may not work. When both sides of the equation of the equal sign are radicals, it's a pretty easy start. To undo a square root, you raise it to the second power. They cancel each other out. So if you do that to one side, you do it to both sides. That's the equality property. So now we have b divide 3 is equal 20 subtract b. Now you could get b to the other side, find the same denominator, all of that. I think the easiest approach here is let's just multiply both sides by 3. I think that's probably the easiest method. So b is equal, 3 times 20 is 60. There's a subtract sign, and then 3b. So we're just going to add 3b to both sides. So we now have 4b is equal to 60. When you divide both sides by 4, b is equal to 15, and then you've got to check. So we're going to, in the radical, we're going to say 15 divide 3 is equal to 20. Subtract b is 15. Well, 15 divide 3 is 5, so square root of 5 is equal. 20 subtract 15 is also 5. So that works out. Okay, so number 4, same thing. You'd start by squaring both sides, and then the radicals signs just go away. Now, the ones where both sides are not radicals, you start off the same way. So we're going to square both sides. Now, this is where it gets a little bit more complex. Notice what we have. We have a quadratic term, something squared. And on quadratics, we need to zero out one of the sides. Since this quadratic is positive, we want to leave it there because if we move it, then we have a negative quadratic we do not want. So we're going to first start off by subtracting a, and then we're going to subtract 20, and that's how we get our 0 over here. So we have a squared, 0 is equal to a squared, subtract a, subtract 20. So this is going to be a factoring, and whatever the results are, we have to check both results. So we find factors of negative 20, but they have to add up to negative 1. So negative 21, nope. Negative 10, 2, they add up to negative 8. Negative 5, these two add up to negative 1. They multiply to be negative 20. So a plus 4, a subtract 5. Now, remember, we could do the zero property rule and then solve for a. A subtract 5 is equal to 0, add 5. But that's a lot of extra steps. What I like to point out to students is that if you look in here, what would you add to positive 4 to get it equal to 0? Well, you just take the opposite, whatever the opposite number is. So in this case, a would equal negative 4. In this case, a would equal 5. Now you have to do the checks. So we're going to do 20 plus negative 4. Well, that's going to be the square root of 16. And unless we put the negative sign there, which we have not, this one does not work. Now, some would argue, well, wait a second, that's positive or negative. You do that when you are finding the roots of a known quadratic, but in the form that it is right now, just the square root of 16 is equal to negative 4, that one doesn't work. So now let's check the other one. 20 plus, we're going to put 5 in there, is equal to 5. Yep, the square root of 25 is positive 5. So in this case, the answer is 5. Negative 4 is extraneous. All right, that's it.